Hello everyone, this is Pamperchew. Before I start the video, I'm going to put on my new slippers. These things make me go so fast. Look at that, they make me run fast. They got rubber traction, and since they're so tight, and they go around my heels, I can run fast. So, think thermally. So, what I'm doing today, I'm doing a load test on some of my wiring. I have my thermal camera here. It's all cooled down to the level it needs to be to cool. And you can see if I move it around here. Maybe I turn off one of the lights. Does that help? I can turn off this light. There we go. Let's look at me so you know what I look like. Well, I'm gonna dial it in, but get my face in there. Hold on. For the back. Hold on, I haven't dialed it in yet, so. What's wrong here? Am I going the wrong way? Shit. Hold on. I can fix this. Turn it off. Turn it on. And it'll go back to resetting. Now you can plug this into a better monitor. It has the ports on the back. But right now I'm just trying to calibrate it to my face. Let's get the cord. There we go. And then I go to image. There I am. You can see my face. So that's the thermal image. 60 feels per second. So let's take a look at, so what I have here is all my stoves on. Now they cycle. I can repeat all the switches so they all turn on. And I have this fan here, so it's using the most power it can do. It's actually heating the house. Since I've been running it, it was at 62, it's now at 67. So it's heating the house. And I also have the boiler on. So this is heating the house. If my furnace were to ever go out, I always have heat. In fact, your computer, the lights in the house, these are all incandescents. They heat the house too. But here we got probably a couple thousand watts, maybe 3,000 watts, and this is a 2,000 watt when it kicks on. So I thought we can take a look at the circuit breaker panel after it's been under load for a while. So let's move this. We can move this over here. Actually, we might want it on the floor. So let me move this guy over here so that we can move the camera. I might even put it on the floor. So point at me. There we go. You can see me in the image there. I'm out of focus. Am I out of focus? There we go. Can focus me. But we're going to want to look at the wiring here. So I'm going to move this stuff around. I'm going to hit pause and continue. All right. So we have it pointed at the wire assembly. I'm going to move the camera around. I will focus it right about there. So it looks like we have two wires that are getting warm. Now I'm going to touch those wires. My hand, see, there's my hand. I'm going to grab those wires. This one is on this side. So let's move this over some more. There we go. Get it up in the closet. There we go. That's as far back as I can go. So it looks like, okay, this is a reflection right here. That's a reflection of me. If I block my heat, see, that's a reflection. I can block it, the heat coming from me. So that's what you're seeing there is a reflection of my body. All right. But since we're looking at the stove today and the oven, because they're on separate breakers, I already tested that. Here, we can dial it in. There we go. Now we can see the wires better. And remember, that's a That's a metal pole. Hold on, hold on. Oh, there we go. That's a metal pole. So that's see, you can see my reflection. The only wire I see heating up is that one there. Let's see if I can get some more contrast. There we go. So it looks like we have two wires that are getting warm. I see this one here is a little warm. And I see, well, the obvious one. I can dial it down so we can see it better. So there's two wires getting warm. Obviously, one of them, that one there, and that one there. That's for the stove. And also my hand. Look, if I put my hand on another wire, see how I like contaminate it all, especially the metal. So that's just the residual heat. But we see that this wire here, and if we look up at the box, that should be the range. The range. That's a 30 ampere. The oven is a 20 ampere. The oven only needs about 5 or 10 amps. So this is definitely overbuilt. The oven that's in there is a little pussy. Sorry, I shouldn't have used that word. But if I hit this one, the oven will go out. You can see the little lights. Here I can zoom in. And if we can still see the lights going on and off. Okay. And the range, which is a double 30, if I hit that button, let's see if we can see from here. Well, you know what I'm saying, so we don't need to do that one, but you get the point. So we can look back at the thermal image and see this one's getting warm. Now, oh, wrong one. This one's getting warm. Now, I can't feel that to the touch. If we crank it this way, you can see it's about the same temperature, but I don't feel warmth at all. So this wiring is done perfectly. Now if we crank it just a little, we can see that this wire, that probably goes to the stove. Oh, it might be the dryer actually, because I am running the dryer right now too. I'm just doing a load test on the major appliances, just to see what they'll do on the wiring. So when the wire gets hot, that's a good sign. And we're going to look for hot spots. So let me pause it and I'll take the cover off. Okay, so I got the cover off of the panel, the circuit breaker, and I'm going to look for hot spots. That can be any of these screws that might have a loose connection. It'll show hot. So let me figure out a way to arrange this so we can do that on video. Alright, so I've raised the thermal camera so that it can point in the box. We can now look at the one breaker, this one here, that connects to the range. Alright. So let's look at some of the other ones. Hold on, I want to dial this in so we can see more contrast. There we go. So we're looking at the connections itself. Now those look perfectly fine. Let's tilt up. You can see a little heat coming from that one. Sorry, this isn't the best way to do it, but I'm going to pull this out so I can hold it. And what I'm seeing is one leg is getting kind of hot there. If you see, get this thing turned around. I got a kink in the line. There we go. There's the one we're looking at. Let's go. I'm trying to get a hold on this thing. There we go. So you can see that connection has a little bit of heat. Now we're talking about just less than 10 degrees difference. But this line here, let me turn the light on. This line here is getting a bit warm. Now it's not warm to the touch. And remember, this is the one, it's not, you can't feel any difference. But it's cool to watch, it's cool to look at it and to see where the heat happens. So what we want to know is if there's any hot spots, and I'm going to look for them right now. Since it's really hard to do a video camera and do this at the same time, I'm going to pause it. Now, of course, this is the only hot thing because this is the only thing I'm running. But we can now determine that there's no problem with this part of the house. The stove and everything works fine. That works fine. We can turn this all off now because I'm getting really hot. I'm wearing a bunny suit. Here, I'll show you. Yeah, this is my work clothes. This is my work clothes. Foo. You don't know me? You don't know me? I do what I want. Oh, my ears. Oh, my God. I was a tweaker bunny for a second. Okay. So everything looks good on those lines, and later I will load down every single line. Like, see how that looks a little loose? Well, it might be loose, but it should still be a good connection. Now, all these are hots, so you don't want to touch those. Here, I can do a brief. I can turn this thing off now. You can hear it go in reverse. It's a cooler that uses a pump, but when you shut it off, the heat goes in the opposite direction, so it'll run reverse. So anyway, this is your neutral, one leg and two legs. Now between those two is 120 volts, or 120 volts. Between those two is 240 volts. So inside a circuit breaker, the legs go back and forth, back and forth, back and forth, so that when you plug in something on this side, you have one leg and the other leg. That wire and that wire. For things that use just one side or the other, you have simple ones, like that's the lighting, but that's one leg, so that's 120 volts. And the other piece of the wire connects to this neutral bus bar. This is one I can touch. See? I can touch that. And this is all neutral there. Same thing on this side. That's neutral. You can touch that. You could touch this too, but it might give you a little jolt, especially if you're grounded. So if I had my clothes off and everything, yeah, it might buzz a little. I'm not going to play around with this though. That's 200 amps available right there. And if I'm grounded just by accident, you know, I'm sweaty, I'm stepping on the floor, hey, this will conduct some electricity. You'll get a little bit of current. It won't kill you, but it doesn't feel comfortable. So that's your neutral, one leg and the other. And so you got leg one, leg two, leg one, leg two. So it goes 1, 2, 1, 2, 1, 2, 1, 2, all the way down. Those would be 1, 2, 1, 2. And so it swaps back and forth. If you've never seen the part behind circuit breakers, go ahead and look it up. But that just allows you to have one of each leg, one leg, two leg, and the neutral, which is also connected to the ground. If you look very carefully back here, that's where all the ground wires come in. But if you're paying attention, that's also connected to the box, which is connected to this. So this connects to ground at the box. If I look in there, you can see in there. So that's tied to the chassis. This is my main. I love to trip the main. Everything goes out. It's so beautiful. And my refrigerator likes to chime when the power comes back on. But yeah, I'll probably eventually go in and just tighten each one, but you know, see how things can be loose? Something like that could cause a resistance in the connection. If you're running it at a high load, you can have a high resistance. It causes a little bit of voltage drop, but it also wastes a little bit of electricity. The stronger your connections are, the more efficient your wiring is, and also your appliances. When you have a voltage drop, current goes up, and a lot of the current gets wasted between a bad connection. Have you ever had like a vacuum cleaner and you pull the plug and it's hot? Or a toaster and you pull the plug and it's hot? That's because you have a bad connection to the wall. Those plugs, they tarnish, you just need to sandpaper them. Same thing with your outlet. If an outlet always has something hot when you're unplugging it, it's a bad connection. Like, okay, well, those look silvery, but old toasters and old appliances, vacuum cleaners do it too. Anything that uses a high amount of current, you want to make sure your connection to the plug is solid. Otherwise, you're wasting electricity, and you're heating this part up. Now, it's not likely to start a fire, but that's how electrical fires start. A loose connection, high current. There's one time in my bedroom at Steve's house, I just had my heater plugged in and nothing else. That was when I was really depressed. I shut my computer off. I did nothing, but I needed a little bit of heat. And I had my heater plugged in, and all of a sudden, smoke starts pouring out of the switch outlet. I don't know why it was wired that way, but I opened it and I saw the little wire nut. One of these things, a wire nut. It had melted off, and inside was 3 or 4 copper wires glowing red hot. So what happened there was the wire nut was not making a good contact, and the current flowing through one wire to another created so much heat because it was barely making contact. It got red hot and it burned the little nut off. This is what I did basically. When I saw it and it was melting, I pulled off the plastic part, and there was the metal part that is inside, still attached to the wires, and they're glowing red hot. So I pulled the plug and I told Steve, and he didn't fix it for like a week. I couldn't fix it. I knew his wiring was bad. He's getting older. He's making mistakes. He had made a wiring mistake that causes 3 breakers to go off at once. Basically, he had 2 breakers that were tied together in a loop, and that functioned. Very dangerous. Basically, 2 15-amp breakers tied at the end somehow. So it was allowing 30 amps to all the plugs. That's why my computer probably ran with the air conditioner, with the microwave all at once. Now, these wires are, of course, made for high temperature operation, but when the mistake happened, when he attached a 15-amp breaker to that line on the other leg, it caused all 3 of them to overheat and go off. So when you tie a couple breakers together on the same leg, you won't notice any problems. You'll just have the ability to pull twice as much current through those lines. And 30 amps on a 14 gauge is not that big a deal. You don't want to do it. You just don't want to do it, but it will work for a period of time. Now, I wasn't using 30 amps, but I was definitely using more than 15. And so when he had a 15-amp breaker connected to 2 15-amp breakers on the other leg, it caused... it caused all 3 of them to go off. I usually you'd think just the one would go off, but it could have been he had a double-double. 2 15 amps on one leg and 2 15 amps on another leg, and he connected them, but only 3 went off. So, anyway, I was standing there when it happened. He was too. I saw all 3 go off. I hit this button. I said, Steve, stop. You did something wrong. He was getting mad at me. It's like, no, we were working on electrical that day. He was adding plugs to my room from the old hot tub line, taking what used to be a double 20 and splitting 1/2 to my room, 1/2 to the... Oh my God, it was just horrendous. And I stopped using all the electricity because I was getting scared of a fire after the thing melted. All right. Hope you enjoyed your video. Look at how good my hair's getting. I've been taking baths every day now. I hadn't taken a bath like in 3 years. Steve's house couldn't even use the damn bathroom. And then my mom's house doesn't have a bathtub. And I don't really like taking showers, so I did showers like once every 6 months. But now, look at me. My hair's coming back. It looks good. And I lost weight. I lost a lot of weight. I lost 10 pounds in the last 6 months. So, here, let's try it. Let's see if oh, I can't do it that way. There's my pills. I was going to see if I can open it that way and open it this way so we can do a infinity reflection, but this idiot put it on backwards. So you gotta flip it. It should open this direction, and that should open this direction. And a painting should go right here. I don't know what they had on here. Probably a mirror. You don't want a piece of glass that big in a bathroom. No. Bad decision. Bad decision in a glass. That was a pun. I didn't mean to, though. Bad decision in a glass. Yeah, don't put a piece of glass up there that big. Got my dimmers. Dim. Do not plug in the vacuum, because I don't think... This is a 600 watt incandescent dimmer. So that means inductive load 600 watts. That thing probably uses twice that amount of power. So I'm going to have to get some more powerful dimmers if I want to dim my vacuum cleaner. Which I have. I can get those. Not a big deal. I can get those. I got some surplus stuff here. That's a 1,000 watt dimmer. Look at that one. Oh, it's pretty cool. It has a small knob though, but yeah, 1,000 watt. I'm going to put an iced tea jug, big 5-gallon tank on my refrigerator, so I can dispense iced tea in my fountain. Right now, there's nothing, but you can hear there's a. Here, I turn the fan off. You can hear there's a pump. So I don't really need to have gravity at all. I mean, the tank could be underneath, but I'll put the tank on top, and it's pumped. And iced tea is not carbonated. I won't have sugar in it, so it'll work. It'll work. Wow. I showed a lot today.